Hi, we're here today to talk about the sequence of operations for a efficient gas-fired furnace. So this could be a mid-efficient furnace or a high-efficient furnace. They operate very similarly. Now you'll notice this sequence of operation is similar to the basic forced air gas-fired furnace that we talked about before, but it's just got a few extra steps and a few extra safety devices in place. Well, with this, the first thing that it's going to start off with, just like every other furnace, our house is going to cool down. Now, once the house cools down, of course, we know that our thermostat contacts are going to close. And this is the same thermostat contacts as we would have had before, right? So we are going to have an R terminal and a W terminal, right? The temperature is going to fall, causing that thermostat contacts to close. So T stat closes. Now the difference here is our R and our W are actually connected to the electronic control board, right? They're not directly wired in with the main gas valve. They are connected to an ECB or an electronic control board. So from there, once our thermostat closes, like I said, it sends an electronic control board, a signal to the electronic control board. The electronic control board signal is going to fire up something which is called a combustion air blower. Can also be called an IDM or an induced draft motor, but I'm going to call it a combustion air blower. Now what this combustion air blower does is it's going to pull air through the heat exchanger. So it draws in fresh air from outside, takes in cold air returns from our ducts, and blows it through the heat exchanger and then out the flue. With this combustion air blower, we need to ensure that there is actual air movement happening. So what we have is a normally open pressure switch called an air-proof switch. And the air-proof switch, is going to close, and it's going to prove to the electronic control board that the combustion air blower is working correctly. So it's going to be an input to the electronic control board. Then the electronic control board is going to output to our ignition source. Now this can be one of two things, and this is where it gets a little tricky. It can be an HSI, a hot surface igniter. And with the hot surface igniter, we're going to energize the hot surface igniter from the electronic control board, and it is actually going to take some time. The hot surface igniter needs time to eventually heat up, whereas the other type of ignition is known as, or a DSI, a direct spark ignition. Direct spark ignition doesn't take any time. It's ready to go right away. Both of these are going to lead down to my MGV, my main gas valve. It's going to open or energize. Right, so if it's a hot surface igniter, a little filament that gets very hot, it takes time for that to warm up. Then my main gas valve opens. With the direct spark igniter, the direct spark is going to start. At the same time, that main gas valve is going to open. So once we see that main gas valve open, what we see is we have an input device, and we call it a flame rod. What this flame rod is it's a single conductor hooked up to a rod which is in the flame. What it's going to do is it's going to provide flame rectification. So it's going to send a small AC current down the flame rod. It's going to use the flame as a path for current to flow back to the chassis ground, and you're going to get a DC signal back into the control board. So what it does is it's going to prove flame. right? And if there's no flame, it's going to try and ignite it again and try and ignite it again, and then it'll shut the system down. So what this flame rod does is it's going to send that signal to the electronic control board. Once it proves that there is flame, now the HSI, the ignition, is going to de-energize. Right, so my HSI or my DSI is going to turn off once we know that there's an actual flame there. Then, now the flame is going, the burner is ignited, and it's heating up in the plenum. We are going to see ECB timing. So the electronic control board is providing timing. After a certain amount of time, and it's non-adjustable, right? It comes preset from the manufacturer. The manufacturer knows how long it takes to heat up the plenum. We see the indoor fan motor energize, right? This is warming up the house. It's blowing the warm air from the plenum into the house. So we see the house now warming. Once we see the house warming, it's getting a little tight along the bottom here. We see that thermostat contact, right? The same thermostat as before, fed from R and W of the electronic control board. Temperature rises, it is going to open. When it opens, it sets or sends a signal to that electronic control board, which is going to MGV, closes the main gas valve, or we can say it de-energizes the main gas valve. Once that main gas valve de-energizes, the combustion air blower is still running, it hasn't turned off, and the indoor fan motor is still running, it hasn't turned off. We see a timing elapse. We see about 10 to 15 seconds, and then we see some things start to de-energize in a sequence. First, we are going to see the combustion air blower do what's called a post-purge. So it'll continue running just to make sure all that combustion air is taken through the heat exchanger and pushed out the plenum. Then, after another period of time, so we've got some more time, and this time is often adjustable. Right, we can set this using the dip switches on the control board. Eventually, we see that IFM de-energize. Once we see that IFM de-energize, there's no more hot air blowing through the house. Obviously, we are going to see the house is going to start to cool down again. So that's our sequence of operations, right? And it is, again, that closed loop control. So we're seeing it start with the thermostat contacts closed, and it runs all the way through the sequence. Now, we do have some new components here that we're dealing with that we did not have before in a basic furnace, right? We have that combustion air blower, which purpose is to move that air through the heat exchanger. We're seeing a new type of ignition source, right? The HSI or the DSI. So just some new components to learn, right? We're seeing this flame rod is proving the flame now instead of a thermocouple, and it has a much faster response time. It's almost instant, right? We are seeing now just all of these signals happen into the electronic control board, and we're not actually seeing them do an electrical function. They're just signals into the electronic control board. So we've done all of our inputs to the electronic control board in green, and we've done all of our outputs in red, right? So we are going to have controls and we are going to have loads in this system. Now, one thing to keep in mind with this system, which is very important, is we still do have lots of these guys in place. High limit switches. So we have a couple on our furnace where we have a primary high limit, which is in our heat exchanger. We also have a bunch of secondary high limits placed around the furnace, all wired in series, and any of them are going to open up should there be a high limit condition. We also now have something called a roll out switch, which is another type of high limit. And that rollout switch is placed next to the burners, and it just ensures proper alignment of the flame, right? When our main gas valve opens and the flames are ignited, you just want to make sure the flame position is into the heat exchanger. So that's what those rollout switches are for. A lot of information we've covered right now. I do hope that this helps you out a bit. Thanks for watching. Be sure to watch my other videos.